Hello and welcome back to the channel. Today I'm taking a look at Hi3D, or Hi3D as they're now named, which is an image to 3D asset generator. The idea is pretty simple. You start with an image, upload it, and the service generates a 3D model from that image. But what I really wanted to know is whether these models can actually be used for 3D printing. Because generating something that looks cool on screen is one thing, and getting a usable model that slices cleanly, prints well, and does not turn into a support removal nightmare is a whole different thing. So for this video, I decided to create a small set of steampunk style assets. I generated concept images, brought them into Hi3D, created 3D models, cleaned up or adjusted the models where needed, and then printed them on my Bambu Lab A1. By the end, I had 4 printed models: a supply chest, an energy battery, a mechanical compass, and a segmented steampunk robot. And honestly, some of these came out better than I expected. For this test, I wanted to do more than just upload one random image and call it a day. I once ran a Kickstarter where I commissioned some characters and world props for a post-apocalyptic setting, so I wanted to do something in that spirit. But instead of hiring artists and modelers for every object, I wanted to see how far I could get by creating concept images and using Hi3D to turn those into printable models. I ended up going with a steampunk theme because it has a good mix of materials and details: wood, brass, gears, pipes, and chunky mechanical shapes. That also gave me a good way to test the generator. These are not plain cubes or simple toy shapes. They have detail, but they are still objects that should be printable if the model comes out clean enough. The first object I tried was this steampunk supply chest. I started with a concept image of a wooden and metal chest with brass corners, gears, rivets, and some mechanical details on the front. For this one, I used the standard image to 3D tool and went straight to the quality mode. I had not fully planned out the entire video yet, so this was basically my first real test to see what the generator could do. And the result was actually pretty good. The model captured the overall shape of the chest, the metal bands, the gear details, the pressure gauge, the latch, and the side hardware. For something that started off as a single image, I was pretty impressed with how much of the design came through as actual geometry. I exported it as an STL and brought it into Bambu Studio. Here I had to do a couple minor things. The first, of course, was to get supports turned on. I also boosted up the quality a bit since I wanted to give it the best chance to show some of the details in these models. Also, since my source image had perspective, the output model is not flat to the ground plane, so I had to use the lay on face tool to align it to the plate. Other than that, I just let it go. The print itself came out pretty nicely. The only issue I had was on the underside. The original design had these small raised corner feet, so the bottom of the model was not completely flat. That meant supports had to print underneath parts of the chest, and they were a little annoying to remove. But that is not really a problem with Hi3D, that's more of a design for 3D printing issue. The image I used had a non-flat bottom, so the model had a non-flat bottom, and then the print needed supports. That was a good lesson right away though. The better you design the input image for 3D printing, the easier the final model is going to be to print. For the second object, I wanted something a little different from the chest. So I created the steampunk energy battery or power cell with a glowing crystal core, pipes, rivets, brass parts, and a heavy base. And I wanted to test a little bit more of the workflow. I wanted to test multi-view, and this is where things went sideways. However, the blame is on me and the source materials. You see, the multi-view requires you to have at least a front view and then any supplementary views like the back or side views. However, my source material was a perspective view, so in between the top and the side, and the back and the side. So when trying to generate the image, the algorithm basically created a mix of both, which led to duplicated features since it thought the details belonged on both the front and the back. So if you're going to use the multi-view feature, make sure you really have images that are from the front and back or side views. With that, I went back to the original single view mode. I then wanted to test with fast mode, mostly to see if the overall shape was going to work. This image has partly hollow inside, so I wanted to see how fast mode would handle it. Fast mode is useful because you can get a result faster and decide whether the design is even worth pushing further. It handled it pretty well, but there were some features that did not have the level of detail that I was expecting. Still, it was pretty good. I then ran the same image again in quality mode. quality mode version gave me a better model, and that's the one I decided to print. You can see here that there are a lot more details in the model, and the features from the image are represented well. One thing I noticed with this model is that the file was pretty dense, so I used the decimate feature on the Hi3D site to lower the polygon count. There's a variety of editing tools, and one of the more helpful ones is decimate. I entered edit mode and went to the decimate tool. I brought the model down to something more manageable before exporting it and bringing it into Bambu Studio. That is a feature I appreciated because for 3D printing, I do not always need some massive high poly file. I need the model to still look good, but I also need it to be practical to work with in the slicer. Once I had the decimated version, I brought it into Bambu Studio, sliced it, and printed it. There's not much to show there for the bamboo part, so I'll skip it. This one also came out pretty nice. Some of the small side details were delicate, and I did break the little clock or gauge piece while removing supports, but I was able to glue it back on no problem. It is one of those things that you run into with any detailed print, especially when there are small protruding pieces. I'll show you the end result in a bit. The next object I made was the Steampunk mechanical compass. For this object, I wanted to try the image editing feature. It basically allows you to run a prompt on the uploaded image to make changes. So I wanted to simplify this model a bit and make it more suitable for 3D printing. I wrote up a prompt and used it to generate a new version. If you toggle between the old and new image, you can see how it simplified a lot of the details that were in the image. It took the texture that contained a lot of noise and normalized that a bit more into flat colors, which are easier for the AI to convert. Now that I had this new image, I went ahead and generated a 3D model. Once again, I chose fast mode to see how the model would look like. It came out pretty good, but once again, some of the highly detailed features were a bit off, including the gauge and the bottom of the compass. I decided to generate it again using quality mode. I switched to quality mode and opened the advanced tab to lower the polygon count to about 1,000,000. This way Bambu Studio won't complain. Then I hit generate and checked out the new version. This time I see more of the details I was expecting. We do have one issue where the bottom of the compass has a hole and it's hollow. Let's see how Bambu Studio handles it. I'm going to go ahead and export and print it. For the final model, I wanted to do something more character-like. Up to this point, I had mostly created props, a chest, a battery, and a compass. So I wanted to see how Hi3D handled something more complex and recognizable as a character. But I also did not want to create a super complicated model that would need 15 tiny pieces glued together. So I went with a small steampunk helper robot. The design has a big round head, large goggle-like eyes, a chunky torso, short arms, short legs, a small backpack tank, and an integrated base. For this one, I also wanted to try Hi3D's new segmentation feature. But before I could use segmentation, I first had to generate the actual 3D asset through the normal image to 3D tool. So I uploaded the robot image, selected quality mode, and adjusted the polygon settings. I did not want an unnecessarily massive file, so I toned the model down to around 1,000,000 polygons again. Then I generated the robot model. Once that was done, I went over to the segmentation tool. The nice thing was that my latest generated asset, the robot, was already loaded into the segmentation area. But I also show here that you can either choose from your generated assets or upload a local model if you already have something on your computer. From there, I had to choose a split template. For this robot, I picked a template that splits the model into 4 parts, the torso and head together, each arm as its own piece, and the legs together. There were other options, but because the robot had this piece attached to his feet, I could not really choose a template where the feet were separated individually like the arms. The base made the bottom of the model one connected section. So the only template that really made sense for this model was torso and head together, both legs and base together, and each arm separated. I do wish there was another option where the head was separated from the torso. That would have been useful, especially for a character model like this, but that was not one of the available templates, so I made do with the closest one. After choosing the template, I generated the segmented version. Then I used the explode function, which is a really nice visual way to see how the model has been split up. You can see the torso and head move away from the legs and base, and the arms separate out to the sides. This is the kind of thing that could be useful for printing. Instead of printing a whole character as one model with a bunch of difficult supports, you can potentially bring each major's parts separately and assemble it afterwards. Let's see if we can do that. After exporting the segmented model, I brought it into Bambu Studio. One thing I forgot to mention is that there are a variety of export formats, including GLB, STL, and 3MF, which Bambu Studio reads well. When importing the 3MF, Bambu Studio read the color information and asked me to assign it to existing colors or to keep them as is. As you can see, since I exported in split mode, they came in the same way. I'll go ahead and split the assembly into their own parts first. I then separated the parts across different plates. The base came in a little wonky at the bottom, so I used the cut tool to slice off the uneven lower portion and create a flat base. That made it much easier to place on the build plate and print cleanly. There was really not much to do on the head and torso. The orientation was pretty good and the amount of supports was minimal. I kept looking around for possible issues, but this seemed to have come in at the right orientation, so I mainly left it alone. I put both arms on one plate and rotated them to get a better print orientation. After getting everything on their own plate, I went ahead and printed each one separately. And here we have all the pieces of our robot printed. The legs and base look pretty good. There weren't many supports to deal with for them. I see a slight issue on the bottom of the base, but nobody will ever see that. The arms though, I think could have used better positioning. There were brim supports where the arm was touching the plate and left a support residue when removing. That's a mistake on my part. I should have looked for a better way to orient them to print with less supports on the more visible areas. The head and torso came out great. There are a small amount of overhang issues under the head, but nothing crazy. One thing that was really great, and part of what Hi3D is offering with their segmentation tool, is that the generator creates slots for the segmented parts. You can see here how there are indentations on either side of the torso where the leg pieces will connect into. The arms were a different story, but the legs connect really well. There's a good slot on each side, and the torso pops onto the legs securely enough that you can even make the robot bow forward a bit and it stays connected. The arms did not slide in as well. They lined up visually, but they did not have that same secure fit as the legs and torso. So for final assembly, I'll be using a little super glue to attach everything together. And once it's all assembled, the robot came out looking really good. It was definitely the most complex object in the set, and it was a good test for both the image to 3D generation and the segmentation feature. So after all of that, I ended up with 4 printed models: the Steampunk chest, the power cell, the compass, and the robot. The chest was my first test, and it showed that Hi3D can turn a detailed concept image into a usable printable prop. The battery let me test quick mode, quality mode, and the decimate feature. And it also taught me that multi-view generation needs proper front, side, and back references if you want it to work correctly. The compass was probably one of the cleanest single color prints because all the important details were physical shapes. And the robot was the most complex model in the group. It gave me a chance to try segmentation and print the character in separate parts. Overall, I came away pretty impressed with Hi3D. It's not magic, and the input image still matters a lot. If your concept has fragile details, a weird base, too much transparency, or the wrong kind of views, that can affect the generated model and the final print. But when you give it a clean image with a clear silhouette and shapes that make sense for 3D printing, it can produce some very usable results. For me, the most interesting part is not just that it can generate a model, it's that it can fit into a real maker workflow. Create or edit an image, generate the 3D asset, reduce the polygon count if needed, segment the model if it's a character, bring it into Bambu Studio, and actually print the thing. That makes it useful not just for digital artists or game assets, but also for regular people like us who want to turn ideas into physical objects. Anyway, I'll leave the link for Hi3D down in the description if you want to check it out. And as always, thanks for watching the Custom Corner. If you enjoyed the video, hit the like button, subscribe, and I'll see you on the next one. Thanks everyone.